Okay, so continuing systems of equations elimination method. Let's go down here and do another example. So example number 2, and we've got our first equation is 1/3 x minus 1/2 y equals 1/6. And our second equation is 3x minus 2y equals 9. So don't let fractions freak you out, guys. We're just going to use an LCM of, in this case, 6. So just like we've been doing all semester long, because this is an equation, I can use an LCM and get rid of these denominators, and then I don't have to worry about it, okay? So these are gone. That's 3, that's 2. So now my equation number 1 is actually 2x minus 3y equals 1. And my second equation is 3x minus 2y equals 9. Okay, so now I'm going to look at this. Well, I can decide to get rid of x or y. Doesn't matter which one. They both have the same sign, so I'm going to have to use a negative in one of them. And they both will end up having to be 6. So I guess it just really doesn't matter. So I will choose y. Just arbitrarily. I just felt like y. So what do I need to multiply with this 3 to get 6? Well, it's going to have to be 2. But you know what? I'm going to multiply this one by negative 2. That way the top will be positive and the bottom top y will be positive and the bottom y will be negative. Just feels better. But I could make the other one, when I do number 2, be negative instead. Okay, so negative 2 times 2x is going to be negative 4x. And negative 2 times negative 3y is going to be positive 6y. And negative 2 times 1 is going to be negative 2. Then what do I need to do with multiply with the 2? And here I'm not going to change its sign, because remember, the in front of the y, my coefficients need to be the same and my signs need to be opposite. So what do I need to multiply with 2 to get 6? Well, I need to multiply with 3. So now 3 times 3 is 9x. And 3 times negative 2 is 6y. And 3 times 9 is 18. Put a line. Don't forget that line. It really does help. Now I'm going to add these up. Remember, we're always adding. Another reason why some people call it the addition method. So that's going to give me 5x. My y's are eliminated. And, oh, wait just a second. 3 times 9 is not 18, it's 27. I hope somebody caught that. Okay, so 27 minus 2 is 25. And now when I divide 5x by 5, I get x. And 25 divided by 5 is 5. So now when I look back at the original problem, so these two, which equation do you think I want to put my 5 into to find out what y is? I hope you all yelled 2. You could put it in 1. You absolutely could, but it's going to be a lot more work. So let's put it in 2. Okay? So I'm going to put it in equation number 2. Always label what you're doing. This doesn't seem like it's very big deal now, but when you get into 121 and you're doing 3 and 4 equations, labeling these equations can be a very big deal. So 3x, and my x is 5, minus 2y equals 9. So now this is 15 minus 2y equals 9. And I'm going to subtract 15 from both sides, and so I get, that's negative 6. then divide both sides by -2, and I get y equals 3. So, okay, my point is 5, 3. Now to check it, I have to put it into the original equation again. So let's do that. Now don't let the fractions freak you out. So equation number 1, 1/3 x minus 1/2 y, and I'm getting my x and my y from these guys right here, okay, equals 1/6. So I can't cancel anything anywhere, so I've got 5/3 minus 3/2 equals 1/6. So on the left side of my equal sign, I need to get a lowest common denominator, and it's going to be 6. So 3 times 2 is 6. So if I multiply, let me do it like this. So anybody who needs to see this, what do I need to multiply with the 3 to get 6? 2. If I do it in the denominator, I need to do it in the numerator. Now what do I need to multiply with the 2 to get 6? 3. If I do it in the denominator, I need to do it in the numerator. And the right side I didn't have to do anything with yet. And so now I've got 10/6 minus 9/6 equals 1/6. And 10 minus 9 is 1. So 1/6 equals 1/6. But that's only one equation. I have to check this in both. So I need to check it in the second equation. So 3 times 5 minus 2 times 3 equals 9. So 3 times 5 is 15. -2 times 3 is -6 equals 9. And 15 minus 6 is 9 equals 9. So my answer, the point 5, 3, the one point where these two lines cross, is indeed 5, 3. Sorry, it just happened to be exactly like the other one, but most of them are different. Okay, so now we need to look at some exceptions, okay? So let's look at this. 2x plus y equals 6. And, oops, my second equation is -8x minus 4y equals -24. Well, when I look at these two, this is hard to see. When I look at these two, both x and y have opposite signs, but my x, the coefficients will have to be 8. The coefficients for the y will have to be 4. So I'm going to go with eliminating y. So what do I need to multiply with this y to get it to be 4? Well, it's got a 1 in front of it, so it's going to have to be 4. So 4 times 2 is 8x plus 4y equals 24. And I don't need to multiply anything with the second equation, so I'd leave blank what I'm going to do there, and I just write down what it is. And now I'm going to add them up, okay? And when I do this, I end up with 0 equals 0. Finish this, guys. If you do not, you won't know what to do, okay? So this is not an answer. 0 equals 0 is not an answer. What this means is, so like 95% of the time, you are going to get the one point where the two lines cross. But about 2.5% of the time, all the variables are going to go away and you will get something like this. This is a true statement. And what it means is that if I were to graph the first line, it'd look like this. And if I were to then graph the second line, it would look like this. In other words, it's the exact same line. And so what your answer should be here, so the answer to this is infinite solutions. Now, I think in some of my written stuff, I put all real numbers. Ignore that. Because in actuality, all real numbers could be points not on the line. But infinite solutions is every single point on this line as far as this line goes forever. Okay? So your actual answer is this. Now, this kind of system has a name, and the book talks about it. Do not use that. Okay? If you are giving me that answer, that is not an answer. It's just a description, a name for this system. It means you're reading the book. You're not watching my video. Okay. So one other exception happens. Let's look at this. So let's say I've got 4x minus 3y equals 8. And I've got 8x minus 6y equals 14. Okay, so again, I look at this. I'm going to have to mess with a sign in one of them at least. But my x, I would have to go with 8. And with my y, I have to go with 6. So I'm going to try and get rid of y. But you could get rid of x if you wanted. Okay, so in my first equation, I'm going to multiply by -2. So -2 times 4 is -8x. And -2 times -3 is positive 6y. And -2 times 8 is -16. Now, I'm not going to do anything again with the second equation. So I just write it down. Put your line. It makes a difference. I know you guys don't think so, but it will. And now once again, when I add these up, my x's and y's both are gone. But over here on this side this time, I get this. Again, this is not an answer. So this is the other 2.5% of the time. We end up getting something that is like all our variables went away again. But this time we have a false statement because 0 does not equal -2 in this case. It doesn't always come out to this, but it's always a false statement. And what that means is if I were to graph my lines, they are parallel. And where is this going to cross? Never. So what that means is my answer is the null set. So I either have, the only things I ever want to see is an actual point or the word infinite solutions. If you ended up with a true statement, all the variables went away and you ended up with a true statement, or the null set. If you ended up, all the variables went away and you went with a false statement. Again, this has a name. If you're reading the book, you're going to know what that is. I don't care what that is. Okay, I don't want that. That's not an answer. It's just a description of the, system. Okay, so one more video, we're going to do substitution method.